Here's problem number 5.8. So the horizontal surface on which the objects slide is frictionless. If F is equal to 12 newtons, what's the tension in string number 1? So we have a force out front here, a 3F, so that's equal to 36 newtons. And we have a force over here of 2F, which would be 24 newtons. We have string number 1 here, string number 2 here, and we have some masses here, an M, a 2M, and a 2M. Now we're not told what M is, so hopefully we won't have to know that, but let's see what we can do with this. First thing we're going to do is we're going to blob this whole thing together, treat it as one total mass. So we've got total mass of 5M, I'm sorry, 6M, because this is 3M over here. So we have 6M, and the forces we have acting on it, we have 36 newtons going to the right, 24 newtons going to the left. Of course we would have weight, and we would have a normal force, but in this case those forces are going to be transverse to the motion. So as a result of all these forces, this thing is going to manage to accelerate to the right in the positive x direction, and the forces we need to consider are these 36 newtons and this 24 newtons. So if I were to set up Newton's second law based on this nice free body diagram, I would have the summation of the forces in the x direction is equal to total mass, m total, times acceleration, and that is equal to the net force in the direction of the acceleration. Assuming the acceleration is our positive direction, that means my net force is going to be 36 minus 24, or 12 newtons. So the acceleration is going to equal 12 divided by the total mass. And we don't know what the total mass is, but this would be 12 over 6m as it's been defined. So this would be 2 divided by m. Alright, so we don't know anything more than that, and that's the best we can do with this blob. Alright, we want to know the tension in string number 1. So let's try a different blob. Let's blob the first two blocks together like this. And hence, if we did a free body diagram of just those two blocks together, total mass of 3m, then the external forces acting on it would be, well, we'd have 24 newtons going to the left, because we still have that force on the left. But on the right, we are just going to have tension 1. That is the only force that's contacting this blob on the right. And of course we'll have a weight to this, and we'll have a normal force to this, but those will be transverse to the motion, and hence they won't contribute to our acceleration in this case. And we will have an acceleration to the right, which is equal to 2 divided by m. Alright, so let's set up Newton's second law for this free body diagram in the x direction. We're going to have the summation of the forces in the x direction is equal to our total mass times a, and in this case that's going to equal the total force in the direction of positive acceleration. So assuming that our positive direction is to the right, our forces add together will be T1 minus 24. So solving for T1, we're going to have T1 is going to equal our total mass times the acceleration plus 24. Well, our total mass is 3m, and our acceleration is 2 divided by m. And then we have plus 24. So in this case, the m's cancel out. So we didn't have to know what the mass was. They cancel out here. We're going to end up with 3 times 2, So we'll have 6 plus 24, or 30 newtons. So that is the tension in cord number 1, 30 newtons. Now we didn't have to do the blob this way. We could have focused in on the other 3M mass and did a free body diagram of it. Now if we notice that we got a 36 Newton force going to the right, and tension 1 in this case would be going to the left. If I set up Newton's second law just in the x direction for this, knowing that the acceleration is 2 divided by m, and of course we would have weight and a normal force. The acceleration is to the right in the x direction. So we're going to have the summation of all the forces in the x direction is equal to our total mass times acceleration, and that will equal, in this case, the total force in the direction of positive acceleration. So that will be 36 minus tension 1. Solving for tension 1, we'll have tension 1 is equal to 36 minus our total mass times acceleration. So that's going to be 36 minus, and our total mass was 3m, our acceleration is 2 divided by m, m's cancel out, so we're going to have 3 times 2 is 6. This is going to be 36 minus 6, or 30 newtons. So it doesn't matter how we look at this, as long as we set up the proper free body diagram for whatever object we're looking at, we can calculate the tension in that cord number 1.